Hello all, this is 3.4 Sequences and Equations. So a sequence is an ordered list of numbers. A term is each number in a sequence. So this would be a term. Number 1, 2, 3, 4, those are all the terms. There are two types of sequences. There's arithmetic and then there's geometric. Today we are going to be working with arithmetic. So arithmetic sequences are found by adding the same number over and over to the previous term. So for this first one, we see that from 5 to 7, we add 2. From 7 to 9, we add 2. From 9 to 11, we add 2. So we know that we're going to be adding 2 to the next term, which means the next three terms would be 13, 15, and 17, because we would just follow the same pattern. If we look at this bottom example, we're adding 0.3 to each one, meaning that the next three terms would be 2.2, 2.5, and 2.8, because from 1.9 plus 0.3, we would get 2.2. The next one would be plus 0.3 again, which would give us 2.5, etc. So if we look at some of these sequences, you'll notice some different types of patterns. Here we are just adding 1 to each piece. Here we'd just be adding 5 each time. But let's look at this one. From 100 to 10, we could either subtract 90 or divide by 10. But if we look from 10 to 1, we're dividing by 10 again. So that sequence must be dividing by 10 each time. Similarly, if we look here, 3 to 9 and 9 to 27, what we're doing is multiplying by 3 to get to each term. When you multiply to get from term to term, it's called a geometric sequence. When you add to get from term to term, it's called an arithmetic sequence. We're mostly going to be focusing on the arithmetic sequences today and not going to worry too much about geometric sequences, but we will need to know about them later. And so if we take a look at these sequences, we already went over this one, which is the adding 2 to each one. The 2 is our common difference. That is going to be a key piece of figuring out an equation to describe our arithmetic sequence. By the way, this should definitely be in your journal, and you should definitely make a note of that right now. We will talk a little bit more about that in a minute. So for this next one, you see that we're actually adding a negative 4, or subtracting 4 to get from term to term, meaning our common difference is negative 4. So for that one, our next three terms would be negative 9, negative 13, and negative 17, because that's what happens when I go negative 4 more every term. So go ahead and give the next problem a try. So if we look at the next problem, we see that the eighth term of a sequence obtained by adding 6 to the previous term, and they want to know what the next term of the sequence is. Well, if we go ahead and take a look at this problem, you'll see the eighth term. So that means that if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, that means this is the first term, the second, third, etc., all the way to 7, 8, and 9. And they're saying that by adding 6 to the previous term, we got 86. That means our seventh term must have been 80. It also tells us that our next term will also be obtained by adding 6, because it's also an arithmetic sequence. So our term here would be 92. So go ahead and try the next problem. Alrighty, so here it says, what is the 12th term of a sequence obtained by adding 1 to the previous term if the 11th term is 11? So looking at that, that means that if the 11th term is 11 and the sequence is obtained by adding 1 to the previous term, that means that the 12th term would be the 11th term plus 1, which would just be 12. So in this sequence, we are looking for a position to term rule. We're given this sequence. We know that this is the first position, this is the second, third, etc. We can call those each our nth terms, where n is the position of the term. And this one's pretty easy because it's just even numbers, meaning that we can define it by 2 times the position. So it's 2 times whatever the position is, and that will give me whatever term I'm looking for. So in other words, if I'm looking for the 100th term, I would just have to do 2 times 100, because that's the nth term I'm not looking for. And that'll give me 200, meaning if I were to continue the sequence all the way down to the 100th term, it would be 200. But you're also going to sometimes see sequences like this where the position to term rule might be a little bit more complicated. So how could we figure that out? We can use the formula for the nth term of a sequence. This is that formula, which should definitely be in your notes, as should this information here. So a sub n is a plus n minus 1 times d, where d is the common difference, n is the position of the term you're looking for, a is the first term, and a sub n is the nth term. So let's take a look at an example to see how that goes. By the way, the secret thing is a star with a happy face in it. Hello. Okay, moving on to the example. So the sequence is 2, 6, 4, 10, 18. So what I need to determine is my A is my first term, so that's just 2. The common difference looks like we are adding 4 to each previous term. So our common difference is positive 4 because we're adding 4. So now all I have to do is plug that into the equation above, and you can see here that our equation will look like this. We've got a sub n equals 2 plus n minus 1 times 4. We do have to simplify it in order to get our final answer. So we'll have a sub n is 2 plus, we'll distribute 4n minus 4. We can combine our like terms here, so we know that a sub n is equal to 4n minus 2, meaning that any n that I'm looking for, so let's say that I wanted to know what the 100th term was. I would plug that in for n, so that means that the 100th term, or a sub 100, is equal to 4 times 100, because that's the 100th term, minus 2, which would be 400 minus 2, which is 398. So you see the advantage of having this formula, so we can solve for any term within the sequence. Alrighty, on this last page, we have 4 sequences. Using the formula I just pointed out, go ahead and try to figure out which of these expressions matches with which sequence, and I will give you the first one to start you off. So n plus 4 works with this one because the first term is 5, the second is 6, and so forth. So go ahead and try those last 3 examples using the formula for the nth term and making sure to simplify it so that it'll be in the format you see. And that is where we will pick up on Monday. So have a great rest of your weekend.